All right, let's do some Mathity-Math. This video is the conclusion of our most epic vector equation journey. This video we're going to do part D, but if you're just joining us, for part A, we proved that these lines intersect and we found the position of point Q. You can go back and watch that video right here. Ta-da! I'm assuming I can figure out how to link that video somewhere, so if nothing linked up, sorry, my magic trick failed. Okay, in part B, we thought about these vectors intersecting, and we found that acute angle, look at that, I can show you right there. We found that acute angle as 55.8 degrees that was between the two vectors. You can go back and watch that video right here. Ta-da! And for part C, we talked about, let me get straight, there we go. Okay, we verified about this point J, this was given to us, where it goes on line 2, and this is how we verified it. And you can go check that out right here. Ta-da! Okay, in part D, this is us right here. Okay, so it says if point M lies on the line L1 such that the magnitude of JQ is equal to the magnitude of MQ, find the length of the magnitude of JM. Okay, cool. We can handle this. I think we're going to want to do it on a different sheet of paper. I doubt I can squeeze it all in right there. So I'm going to bring over some paper real quick. And what I'm going to do here is I'm going to draw a little sketch to help us see what's going on. I'm also going to write down any given information or previous information we had, and we'll go from there. So I'm going to go ahead and draw a quick sketch. You know, we talked about this. We had line 1. It was a vector. Bam. We had line 2. That was a vector. Bam. We did that. And we also found this angle to be 55.8. We did that in part B. So we have that. And then when we look at this question, right, it says it's referencing J and Q. So we have point Q. Point Q, what we found that was the point of intersection. We did that in the first part A. So I'm going to write that down from what we found earlier. Okay, and then it also asks about point J. So there's J. So the J was given to us in part C. So I have that, so I'm going to write that down too. And this is, -4. A big part of trying to be successful in these questions is really trying to organize your information, see what's going on, and try to understand that. Okay, so now if we kind of put the sketch right here for now next to what's going on, I do want to take a minute and think about this. This right here is point Q. We found that. That's the point of intersection. And point J in the question earlier, it said was on line 2. So on line 2, I'm going to go ahead and put in, right? I'm going to put in point J. And then here it's telling you, well, this JQ, this piece right here, it's actually equal to MQ. I don't have an M, but we know that it lies on line 1. So I'm actually just going to put in an M. Okay, there you go. And what they want us to do is this says, well, find JM. So what they're saying is, what is this? What is that? Okay. Now, I want to kind of rewind this and kind of contextualize this a little bit. Essentially, what they're saying is, what is this third side of the triangle, right? And if you look about this, they told us that JQ and MQ are equal, right? So we know that JQ right here, I'm going to put this little line here, is actually going to be equal to here. So that's just an isosceles triangle. That's what we're working with. These sides are the same. And we're trying to find a third side. And we already have the angle in between. So what we want to try to figure out here is, well, let's try to find this right here, JQ, okay? Well, we have the points, right? So we can find the magnitude. We just have to put it in the formula. So the formula is just going to look like this. I'm going to say, well, I'm finding this right here, the magnitude of JQ, okay? It's going to start with the square root. And you know what we do here is you just do, your x minus your x, square it, add that to your y minus your y, square it, add that to your z minus your z, and square it. So it's going to look like this. 4 minus -4, which is just like saying 4 plus 4. Square that, okay? Add that, right? This is going to give us the length to our z value. So 6, I'm sorry, my y value, 6 minus 18. I'm going to square that. And then add that. I feel like this is distracting back there. I'm sorry about that. Let me see if I can make this look better. Okay. 8 minus 28. I'm going to square that. And now that I got all that written down, I'm going to go back and add my line. I just have found this makes my life happier and easier. Okay, so there you go. That's really good. So now what we do is just do math, right? I know that's pretty vague, but you'll see what I'm saying. Okay, so put my start there. Okay, 4 plus 4 is 8, and 8 squared is, in fact, 64. Ta-da! 6 minus 18 is negative 12, and negative 12 squared is positive 144. And remember, guys, a negative times a negative is always a positive. Don't let your calculator trick you. If you do this in your calculator, here, let's take a second to talk about that. Look. Oops, when I say look. All right. If you put in negative 12, if you put in a negative 12 and you just squared it, it's going to tell you negative 144 because your calculator is saying 12 squared times negative 1. Remember, if you're going to use your calculator for this, you have to encapsulate it in parentheses. And so it says it's negative 12, and then you square it, you get the positive 144. Okay, so don't make that mistake. Anyway, back to business. So we got 144. Wonderful. And then the last piece, 8 minus 28 is negative 20, and negative 20 squared is 400. So plus 400. Okay, now we're cooking. The next part, we just got to add all this up. Let's see here. I can do it like this. 64 plus 144 plus 400. Voila, 608. Great. So we know this is the equivalent of square root of 608. Now, let's take a second and really show what this means. We just found out we know what JQ is. We know JQ is the square root of 608. Awesome. Therefore, because we know they're equal, we also know this one now. The square root of 608. And believe it or not, we actually now have everything we need to solve. That's all it took. Now we are in business. Because now we get to go back a couple lessons or thought processes and go back to the good old-fashioned cosine rule. If you don't remember the cosine rule, let me write it out for you. The cosine rule is, write my cursive here, the cosine rule. The cosine rule tells us that c squared, in this case that would be this right here, that would be my c. C squared is equal to a squared. I'll tell you, we'll make this our a, we can make that our b, just to help you see it. So c squared is equal to a squared plus b squared minus 2a times b, and then you put in cosine. So, okay, just to be clear, it's going to be cosine C. All right, and what they're saying here is they're saying, so you have these two sides, it would be this angle right here. So we'll just usually put a theta in, cosine theta C, and you'll see what it means, okay? But it's referring to this angle right here because it's the angle of the unknown side. The angle of the unknown side, okay? So if C is the unknown side, and you have the angle of the unknown side, you're in business. What you can do here is you can go ahead and take the square root of both sides and make this a little bit easier to see. So it's going to say C is the square root of a squared plus b squared minus 2ab cosine theta of the c. Okay. Okay. All right. Let's do this thing. Let's just plug in what we got. So C is, okay, a squared. Now this is gonna, throw some of you guys for a little bit of a loop, but it's okay. If you think about this, a squared is the square root of 608 squared. Let me just do a little side note here. If a squared is equal to the square root of 608 squared, okay, right? That's what this is saying. We're saying a squared is, okay, well, a square root squared is just the value inside. So instead of writing all that out and doing a bunch of unnecessary math, okay, I'm just going to write 608. Because I could put the square root of 608 and then squared. It's going to go away anyway. So, okay, so I got 608. A is the same as B, so I got 608. Okay? Boom, boom, boom. Minus 2. Now, here we go. For A, now I have to go ahead and put in the actual value a because I'm not squaring it. So it's 2 times the square root of 608. I'm going to parenthesize that. Hope that's a word. And I'm going to put in b, which is square root of 608 because they're the same, isosceles triangle. And then I just put in cosine, and I have this already. I did this already, so it's 55.8. And this just becomes a calculator game. Ooh, be careful, that cosine and 55 are looking very similar. Put that there. Okay. And cover it up. There we go. You guys ready? Here we go. C equals. Let's do some math. 608 plus 608 gives you 1216. Could have done that in my head, right? 6688 minus, this one I definitely can't do in my head. So, that looks nice. Okay. 2 square root of 608. Oops, always do that. 608, hit the arrow over, parenthesis. Another time, square root 608, parenthesis. Then you just hit cosine. Remember, you should be in degree form. 55.8. Boom. Hit enter. Right, so you can write that in. You would write, let's say, 683.493. I'm not actually going to calculate this way. I'm actually going to use my calculator. And again, I could have done this all in one line, and maybe I should have. So I'd say 1216 minus, and I go back and hit all of that. Boom. Pow. There you go. You're going to get, your answer is going to be, C is the square root, what do we got? 532.51. And that's all well and good because actually we do just need to take the square root of that. So again, take the square root. This gives you more accurate because you're not rounding. Boom, pow. And there you go. You can say 23.1. And let's just call it units. Actually, I think if the question was in centimeters, you write centimeters, but they didn't say, so I'll just write units. Okay. If it was feet, you'd write feet, so on and so forth. Boom! There you go. That right there is the length of this right here. MJ, you got it. You did good. Voila. And we're done. Woo! All right. If you got any questions or comments, leave them below. As always, subscribe to Mathity-Math if you want to be notified when you got more Mathity-Math. Thanks for all your hard work. See you later. Bye.